Find the surface area of the solid that is shown. Now this is an interesting one. This one's not a usual shape that we generally see. So it will help to draw the net of this. So one base kind of looks like this. And then there's a rectangle below it. That would actually be this one. And then we've got another one of these given below. So it's going to actually have a mirror image of what we just drew up here. So kind of like this. Oh, a little too far. There we go. All right, and then we can extend out in each direction, like this way and this way, with the rectangles that contain it. First, let's label the sides that we know. We know this base is 6 centimeters, and this side up here is 6 centimeters also. This top is 2 centimeters, so the other section of this is going to be 4. And now we know this whole thing is 10 centimeters for this whole distance from here to here. Okay. So now we know that this long side of 10 centimeters is going to go way out to here. So that kind of matches up in the net. So we know this is 10 centimeters. And now what's the height of the prism? The height of the prism is 10 centimeters. So clearly this height isn't necessarily drawn to scale. Okay, and then if we go this way, this side's going to match up with 6 centimeters from this side. And then we're going to have a 4 centimeter rectangle, so a little bit shorter. And then we're going to have, okay, so this going up, we have to figure this out. We know the whole length here is 10, and we know from here to here is 6, so this is also going to be 4 centimeters. Okay, so we can draw another rectangle that kind of looks similar with a width of 4 centimeters. And then we also have the rectangle where the 2 is. So that's going to be a little bit thinner than our 4. So that's 2 centimeters there. Okay, so this is the entire net of this solid that we have here. And we can calculate the area of each rectangle first. 10 centimeters times 10 centimeters will be 100 square centimeters. And then we'll have 6 times 10, which is 60 in this one. We'll have another one of those, 60, right here. And now we're going to have 4 times 10, which is 40. And we're going to have 40 again here. And then this last one is 2 centimeters by 10 centimeters, which is 20 square centimeters for that area. Okay, now we got to do this L-shaped figure that we have here. So I actually see 2 rectangles. If I draw a segment across here, I have a 6 by 6 square, so its area will be 36. And then we found that this was 4, so 4 times 2 is 8 square centimeters for that part. And then if we add up 36 and 8, we get 44 square centimeters. So the entire area of this one is 44, and it's going to be the same down here. All right, so now we have all of our areas and we can add them up. So let's do that. We have 44, another 44. We have 100. We have 60 and 60, which is 120 together. Then we have 40 and 40, which is 80. And we have another 20. So we have 8 in the ones column. This is a 4. 4 and 4, or 40 and 40 is 80. 2 more is 100. Then I would have 100 plus 80 more is 180. 180 plus 20 will be 200. So we're going to have 0 extra 10s, and we're going to have 200 that we're going to carry over or bring over into the hundreds column. So we have 200 plus 100 plus another 100, which will give us 408 square centimeters. So the total surface area here is A, 408 square centimeters. And I'm going to clear some of the ink off of this so you guys can see the work as well. So we did get the area of 44 for that irregular shape for the top and bottom. And then when we found the area of all of the rectangles, you could add those up separately. And still you will get 408 square centimeters, which is answer choice A.